What is the meaning of dipole? Okay, see, one positive charge, one negative charge, one positive charge, one negative charge is separated by a finite distance. Okay, one positive and one negative separated by a finite distance is called as dipole, and this is called as electric dipole. This is called as electric dipole. And here from center, it is measured that from here to here the length is L, and from here to the center again the length is L. So the total distance between the two charges is taken as 2L. Okay, so you might be getting doubt. In electric dipole, one positive and negative charge is there. You can take separately one positive and one negative charge beside it. Okay, so what is the difference between these two? This is isolated charges. Isolated charges means just generally one positive charge and one negative charge. If you take and keep beside it, there is a attraction which is called as force of attraction. And now one positive charge, one negative charge with a finite distance is called as electric dipole. What is the difference between these two? The same difference as two unmarried couple, boyfriend and girlfriend, and this is a married couple. This can be separated. You can separate one positive charge and one negative charge which are attracting each other, but you can't separate these two. Electric dipoles cannot be separated. This is a married couple, you can't separate them. Just like a married couple. What is the meaning of this married couple? Best example for an electric dipole is HCl, HBr. Okay, all these are the examples of electric dipoles. One hydrogen and one chlorine. Okay, partially positive. This is partially negative, and this type of bonds where hydrogen, which is having a single electron, and chlorine, which is having 7 electrons in its outermost orbit, when they form a bond here, okay, what is going to happen? They are going to form a bond here. What type of bond? See, hydrogen needs 2 electrons, and you all know that chlorine needs 8 electrons for its octet configuration, D8 configuration. Now it's a bond formation is there. It's a covalent bond. I think it's called as coordinate covalent bond. Okay, where a pair of electrons, after sharing, it is moving towards a stronger nuclear enter. It's called as a strong bond. So electric dipole is also a strong bond. The best examples are these are the examples here. You can't separate them because there is a strong bond. Electric dipole it is called as. It's called as an electric dipole. Okay. So what is the So what is electric dipole and what is the formula for electric dipole? You all know electric dipole. If you observe, if you consider here, electric dipole is nothing but this is having a positive charge plus q and this is having a negative charge minus q. Any one of the charge, electric dipole is nothing but any one of the charge and distance between the two charges. These two products. Electric dipole is a product of any one of a single charge and the distance between them. If you make a product, that's called an electric dipole. Electric dipole. Dipole moment also you can call it as. Okay, so therefore, your formula is electric dipole is nothing but 2q into L, like this you can write. Electric dipole. Okay, so here, whenever you take an electric dipole or you take a magnetic dipole, see, in a magnetic dipole is also one north pole is there, one south pole is there, and you are measuring the length from the center. From center to that pole, it is taken as length L. From center to this pole, it is taken as length L, and the distance between these two is taken as length 2L. Understood? So this is also called as a dipole, but this is called as a magnetic dipole, and the pole strength between the two poles is taken as M and M. What is the meaning of pole strength? The strength of a pole either to attract or to repel an opposite poles or same poles. This is called as an electric dipole. Okay, this is called as an electric dipole. थोड़ा पिक्चर है बेटा this is one small concept, simple concept here. Now, the next thing is, the most problems are coming from electric dipole is torque acting on electric dipole. Torque. So what is the meaning of torque acting on electric dipole? So to understand the torque acting on electric dipole, let us consider the electric lines of force. These are electric lines of force, and you are considering one electric dipole. Okay, and the distance between them is this one, and this is considered as a negative charge, and this is a positive charge. Here, the field which is taken as negative, and this is the field here. You consider this as a positive field. Okay. So if you keep now electric lines of force, what is the direction of electric lines of force? I told you, to judge the direction of electric lines of force, you have to keep a test charge in the middle, and you see what is the direction of the test charge. Positive charge, if you keep here, it comes downwards because it's repelled by positive charge, attracted by negative charge. So this is going to be the direction of electric dipole. Okay, electric field direction, this is downwards. So if you keep an electric dipole here, what is going to happen? What's going to happen here? See, this electric dipole is attracted by the positive charge upwards, attracted by the negative charge downwards. So this is positive charge. Okay. And what is the force acting on both sides? Yesterday I told you that force is taken as m. What is that? Force is nothing but q into E. So this is q, but this is plus q, this is minus q, and the electric field is taken as E. And this side force is taken as QE, and this side also force is taken as QE, and this is called as the force which is acting on that, and this is called as couple of forces. Torque are couple of forces, both are going to be same. When two forces simultaneously act in an anti-parallel direction and align this electric dipole along the electric field, now this negative will come this side and stop like this. Okay, now if I draw a dotted line, and extend them, okay, what's going to happen? This is angle theta, and this distance is taken as 2L. From here to here, the distance is taken as 2L now. Okay, now this is considered as A, B, and this is C. Now I have to find out what is the torque acting on electric dipole. How to find out the torque here? What is the meaning of a torque here? See, all of you. Torque is nothing but force into perpendicular distance. You just remember this simple formula. Torque is nothing but force acting into the perpendicular distance. So torque tau is nothing but force is F, and perpendicular distance is this one. Okay, which is considered as AB. Now you can just write sin theta is equal to AB opposite side by hypotenuse, which is taken as 2L. This implies that AB is nothing but 2L sin theta. 2L sin theta. Therefore, torque is nothing but M into B into 2L. Sorry, torque is nothing but Q into E. Okay, so Q into E, and this is also called as 2L sin theta. Okay, so from this, what do you understand? Q, 2QL separately you take, E separately you take, and sin theta if you take separately. Torque is nothing but PE sin theta. This is small p, which is called as dipole moment. So this is going to be your formula. Okay, so I think you understand what I'm saying now. So this is a simple formula for torque acting electric dipole. Torque acting on electric dipole is taken as tau is equal to PE sin theta. Based on this, also 2-3 problems are there in previous year questions. Next thing is work done on electric dipole. What is the work done on electric dipole? See, all of you here also, if you consider the electric lines of force in this direction. Okay, now electric dipole is having two charges. So this is taken as negative charge, this is taken as positive charge. Okay, so this is negative and this side is positive, and the distance between them is taken here as 2L. Now what I am going to do is, I am applying some force on this and trying to tilt it with certain angle in this direction. I am trying to tilt to an angle theta here. This is positive and this is negative. I am applying some force. Okay, I am doing some work. I am doing some work to rotate this and tilt it against to the electric field. Now, this is in a comfortable position where negative is attracting positive and positive is attracted by negative, and it is stable now. It doesn't move. But what I am doing, I am applying some force and trying to tilt it like this. I am applying a torque on that. Just like work done is nothing but force into displacement here. Here work done is nothing but torque into angular displacement. Okay, so in rotational dynamics, in rotatory motion, work done is taken as, instead of force, force is analogous to torque here, and displacement is analogous to angular displacement. That's called as work done. So if I do a small amount of work dW to rotate this to an angle of d theta, small amount of work to tilt to a small angle theta, then we write dW is equal to tau into d theta. Understand? And you all know tau is nothing but, what is that? Tau is nothing but PE sin theta. So dW is equal to PE sin theta d theta. Okay. So I am going to find out the work done here. So work done is equal to integration of PE sin theta. W is equal to PE sin theta. So therefore PE. And what is this integration here? See, integration is from theta 1 to theta 2. Okay. Previously theta 1 was 0. Now theta 2 is at an angle theta here. Theta 1 was 0. It was already aligning along the electric field. If it is aligned along the electric field, that means there is no theta. Theta is 0. It is in the actual position where it should be. But I am tilting it to certain angle theta. So what is going to happen now? PE sin theta is nothing but cos theta. Okay, cos theta. Understood? So cos theta, and limits are from theta 1 to theta 2. Okay, I think sin theta is going to be minus cos theta. Integration of sin theta is minus cos theta. Therefore, W is equal to minus PE. We write cos theta 2 minus cos theta 1. Therefore, W is equal to minus, I will send inside. So P is going to be how much? Minus cos theta 2 plus cos theta. Just interchange the terms. So cos theta 1 minus cos theta 2. Okay. So now here, this is going to be your final equation. Okay. So this is going to be your final equation. Sometimes we will ask you, what is the work done? What is the work done by you to tilt an electric dipole from theta 1, that is 0 degrees to 90 degrees, and what is the work done when the theta 1 is 90 degrees to 120 degrees like this? This type of problems is asked. He is asking us to find out the ratio here now. So what is the formula here now? Work done by W1 by W2 is, here if you observe the previous formula, here PE will be same for both. Anything is changing means the angle is going to be changing here. That is cos theta 1 minus cos theta 2 divided by cos theta 1 minus cos theta 2 in the second case. So in the first case, instead of theta 1 and theta 2 we write cos 0, cos 90, okay, and here instead of theta 1 you write cos 90, and it is nothing but 120. So first you have rotated from 0 to 90, again from 90 to 120 you have rotated, then what is the ratio of the work done by you? That's it. So cos 0 is nothing but 1, cos 90 is 0, so it's going to be 1 here, cos 90 is 1, minus of cos 120 is how much? It's going to be minus 1 by 2, right or not? Is it? So 1 by 1 minus 1 by 2 is nothing but 1 by 1 plus 1 by 2, which is nothing but 1 by 3 by 2, which is nothing but 2 by 3. Am I right or not? Is it okay? 1 divided by 1 plus 1 by 2, which is 1 by 3 by 2, which is nothing but 2 by 3, is going to be your ratio. This type of problems are coming on electric dipole. Now, the next concept of electric dipole is, what is an electric dipole? This is a positive charge and this is a negative charge. This is an electric dipole now. This is an electric dipole, and this is going to be an what is this? This is called as axial line. Axial line of electric dipole, which is passing through the axis of two dipoles. And at certain points, you need to find out what is an electric dipole, what is an electric field intensity because of this electric dipole. What is electric field intensity because of this electric dipole? You have to find out now. So from the center, the distance is considered as d here now, is it? Then after that, from this pole, because this is length L, this is length L, from this pole we write it as d minus L, and from this pole we write it as d plus L. Am I right or not? Is it? So what's going to happen here now? See, if you want to find out electric field intensity at that point, you have to take one test charge and keep there, and test charge is going to be always positive. So what are the forces acting on this test charge? How do you find out that one? See, negative will attract here, which is taken as E1, and this positive will repel in this direction, which is taken as E2. E1 is greater than E2 because negative is very closer and positive is very far. So repulsion will be weak, which I am showing with a smaller vector. Attraction will be very strong because negative is very close. I am drawing with a stronger vector, which is lengther, greater than the E1. So therefore, E along the axial line, if you want to find out, E along the axial line, if you want to find out what's going to happen, E along the axial line, which is nothing but E1 minus E2. So general formula for E is nothing but Q by 4 pi epsilon naught into R square, right? Now this is a general formula. But in this case, what is going to be the formula here? E along the axial line, E1 is nothing but Q by 4 pi epsilon naught. E1 is because of the positive, negative charge, attraction. E1. So, and the distance here is d minus L whole square. Minus of E2. E2 is because of the same charge which is very far. I am considering this as Q by 4 pi epsilon naught d plus L whole square. Am I right or not? Okay. So this 4 pi epsilon naught you did not write again. Instead of that you can write K here. Okay. E along the axial line 1 by 4 pi epsilon naught can be considered as K. So KQ, if you common out, what is left here now? 1 minus 1 divided by d minus L whole square, 1 by d plus L whole square. Like this, you are getting the formula. Am I right or not? This is going to the formula. So if this is going to the formula, what is the final step here? E along the axial line is nothing but KQ. So here, from this one d minus L, one d plus L, which is d square minus L square. Again, one more d minus L, one more d plus L. D square minus L square, both together is taken as whole square. And this is, this comes to the numerator. A square plus B square plus 2AB minus, what's going to happen now? This is coming here, which is A square plus B square minus 2AB is here. Is it? So then what's going to be E along the axial line, which is KQ by D square minus L square whole square. It's going to be left now. Okay, if you expand this one, d square plus L square minus 2dl minus d square minus L square plus 2dl divided by d square minus L square. So it's already present here. So I'm keeping the bracket like this. Nothing is there in denominator. Denominator is here now. So E along the axial line is nothing but K, Q, and d square L square. D square L square is getting cancelled. 4dl divided by d square minus L square whole square. Okay, so here E along the axial line, if you take K is considered as 1 by 4 pi epsilon naught, which is d square minus L square whole square. Okay, whole square, and this I'll write it as 2 separately, and what else? 2 separately I write. Again 2QL I will separate, and D I will separate. Why I am separating here 2QL? Because 2QL is going to be dipole, electric dipole. So your final step is so what is going to be your final step now? 2P B by 4 pi epsilon naught d square minus L square whole square. If D is much greater than L, the distance you are taking is much larger than L. L is in centimeters, D is in meters, let us imagine. So we can neglect. L is neglected. L will be, for example, 0.2 like this. Distance 4 meters is there, and this is 4 centimeters. Then what will you write? 4 centimeters means 0.04. లేదా 40 centimeters means 0.4 meters. So 0.4 or 0.2 again whole square will come 2 to the 4 0.04, which is very small compared to d. D is in meters, that is 0.04 meters, which can be neglected. So this part can be removed. This part can be removed. Then E along the axial line is going to be 2p d by 4 pi epsilon naught. D square whole square is nothing but d power 4. So what is going to happen now? D power 4, d gets cancelled, d cube is left. So EA is equal to 1 by 4 pi epsilon. This by heart program chala custom. Just you can write 2kp by d cube. That's it. Simple ga. And you know what is k? K is nothing but 1 by 4 pi epsilon. 2kp by d cube. 2kp by d cube is just the formula along the axial line. Derivation అనేది గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు. బట్ ఎలా వచ్చింది తెలిస్తే మనకు కొంచెం సాటిస్ఫాక్షన్. ఎలా వచ్చింది అనేది తెలియాలి కంపల్సరీ. యాజ్ ఎ నీట్ స్టూడెంట్ యూ షుడ్ నాట్ బై హార్ట్ ద ఫార్ములా, యూ షుడ్ నో హౌ ద ఫార్ములా ఇస్ కమింగ్. Understood? Because he says find out electric field because of an electric dipole where length where the distance or farther distance under. Farther distance means you have to take this one. Lesser distance means you have to consider this one. So to understand farther distance and lesser distance, you have to keep the formula like this only. You do not cancel L square here. So to know that concept, you should know what is the derivation. Is it clear what I am saying now? That is called as electric dipole along the equatorial line. What is an electric dipole along the axial line? Axial line అయిపోయింది. So if I take the distance as this one, and now this is the center, and this distance is taken as 2L, later I take this as L and L. Now I am considering this is a distance D here. Now I am drawing one line here. Okay, so this is L and this is D, means D square plus L square here under root Pythagoras theorem. This distance also same, D square plus L square under root here. Okay, so if you keep a positive test charge, if you keep a positive test charge here which is taken as Q naught, then what happens to this positive test charge? You just see here. Okay, so what is going to happen to this positive test charge? You see this positive charge, test charge, and this is negative. What is going to happen? This is positive, no? Okay, so because of this negative, there is a force of attraction. There is a force of attraction, and that's why electric field intensity because of negative charge is in this direction, which is taken as E1. And this positive repels. So therefore, electric field intensity because of positive charges in this direction. Okay, this is E1 and this is E2. But one thing you should remember: E1 will be equal to E2 will be equal to E. Both will be same now because this distance and this distances are same. In the previous case, both are not same because this is very closer to negative, far to positive. So difference I have taken. Now, as they are very close, same distance we can write same distance. So this is taken as now E, and this is also taken as E. So in this direction, if you draw a resultant, okay. So this is angle theta. This is also angle theta. Why this is angle theta? Because this is angle theta. This is angle theta. These two are corresponding angles. These two are, if they are parallel, these are called as alternate interior angles. Both will be same. So here E means the component of E in this direction is E cos theta. This is E means the component of this in this direction is again E cos theta. Okay. See here. So because of this positive, this negative, both are attraction will be there. Here because of this positive, repulsion will be there. Resultant is in this direction. Resultant of this component is E cos theta, this also E cos theta. Therefore, E along the equatorial line, this is called as an equatorial line, which is passing through the center of the electric dipole, but perpendicular to the electric dipole. Previously, axial line means that line is also passing through the center of electric dipole, but parallel to the electric dipole. This is perpendicular to the electric dipole. That's the reason why it's called as an equatorial line. Hope you are understanding. This, if you understand, you can understand easily in magnetism also. There also electric, what is said to be torque acting on magnetic dipole is there. Formula is similar. There tau is equal to mb sin theta, w is equal to mb cos theta 1 minus cos theta 2. Here pe, there mb. That's a small difference. Okay, so there also electric what is that, magnetic induction along the axial line, magnetic induction along the equatorial line is there. Same concept is repeated there also. Okay, so what is going to happen? So what is the equatorial line formula? EA, equatorial line, no? EE is nothing but 2E cos theta. E cos theta, E cos theta. This component here, this component combined together in the same direction, 2E cos theta. Then what is E here? See, E general formula is Q by 4 pi epsilon naught into R. But in this case, R is considered as square root of D square plus L square. And what is cos theta here? See, cos theta, if you consider here or here, anywhere you can take adjacent side of hypotenuse, which is nothing but L by square root of D square plus L square, which can also written as cos theta is equal to L by D square plus L square whole power 1 by 2 you can write instead of square root, isn't it? So these are all there here. Now E is nothing but 2E cos theta. Okay, so E can be taken as 2E. E means, what will you write? Yes. So what is E here in this case? E at E is equal to Q by general formula is 4 pi epsilon naught into R. R means D square plus L square whole square. Square means R square means this also square means D square L square. D square plus L square is left here. Okay. So 2E means what is left now? Q by 4 pi epsilon naught D square plus L square into cos theta. Cos theta means adjacent side by hypotenuse, which is D square plus L square whole power 1 by 2 is left. Is it? Yes. This is going to left. So E is equal to 2QL is nothing but P. And 4 pi epsilon 1 by 4 pi epsilon 1 can I take it as K here, and what is left now? D square plus L square. Oh, this is 1 and this is 1 by 2, which is going to be 3 by 2. This is going to be the formula when you consider distance D very closer to the dipole. If it is very far 4 meters and this is 4 centimeters, you can neglect L here. Okay, so L can be neglected in this case. See, if L is much less than D, understand? So L square can be neglected. Why square is neglected if L is small? L is 0.2, whole square means 0.04, still less. Decimal ki square cheste inka tagipotundi, still less now. So what is going to happen now? E is going to be Kp. Okay, so Kp by D square. L is not there, into 3 by 2. So this is getting cancelled now. So E along the equatorial line is Kp by dq. Understood? Is it clear what I am saying now? That's it. Now the next thing is, for example, you are considering one positive, one negative, and you are finding electric field intensity not along the axial line, not along the equatorial line. In this direction, you want to find out electric field intensity because of this making certain angle theta. Okay. Then what happens? Just tell me. Okay. So in this direction, it is considered as 2 Kp by d cube cos theta. In this direction, it is considered as Kp by d cube sin theta. This is angle theta, cos theta, sin theta component. Cos theta means coming along the axial line, sin theta which is Kp. See, axial line means 2 Kp, equatorial means Kp. Denominators are same, but components are different. This is cos theta, that is sin theta. Then if this is the situation, then what is the resultant? What is the resultant? And this resultant you have to find out, which is making certain angle phi. Okay. So how do you find out the resultant now? So E net is equal to, what will you write now? Okay. So we write Kp by d cube whole square sin square theta plus 2 దీనిలో వచ్చి మళ్ళీ 2Kp అంటే sorry you can take expand చేసి రాసుకుందాం so that it will be easy for you to understand. K square P square by d cube whole square sin square theta plus 4k square, 2 to the 4, k square, p square, cos square theta by d cube whole square. So what can you common out here? E net, E neither along the equatorial line nor along the axial line, E with certain angle, okay, certain angle, theta, okay, so certain angle, theta, E theta. What's going to happen? Let us see. So, what are the things common out? Kp, see, Kp by d cube is common. So, what is there inside now? This is sin square theta plus 4 cos square theta. Can I write this as cos square theta plus 3 cos square theta last question? 4 cos square theta, I am writing cos square theta plus 3 cos square. Why I am writing? Because sin square theta plus cos square theta is going to be 1. So therefore, E along certain angle is taken as Kp by d cube, and this is sin square theta plus cos square theta is going to be 1. 1 plus 3 cos square theta is going to be your resultant electric field intensity because of this electric dipole. Then what is this angle theta? Angle phi available. So how do you write this? Tan phi. So tan phi is taken as opposite side by adjacent side. Opposite side is nothing but Kp by d cube sin theta. This is 2Kp by d cube cos theta. Okay. So what is left now? Tan phi is equal to sin theta, that is half tan theta. Tan phi is equal to half tan theta. Into half tan theta, sin theta by cos theta is going to be tan theta, and this is 1 by 2 is left here. Double now, axial line is double, equatorial line is single. So half tan theta. Tan phi is equal to half tan theta. Conceptual order. What is the relation between the angle made by the resultant when along certain angle with the equatorial line? What is the net result and what is the angle relation? This angle and this angle relation, how much it is? Means tan phi is equal to half tan theta. Okay, so what is the net angle made with an axial line? Means what is net angle means this is theta and this is phi combined together. So what is net angle? Net angle is theta plus phi. It is theta and extra phi. So theta, see this one, theta phi. Theta phi. So theta plus phi is nothing but theta plus phi. So here phi is nothing but tan inverse of tan theta by 2. So this can be taken as tan inverse of tan theta by 2. This is along the dipole moment. This is the total story of a dipole moment. Hope you are understanding now. Total story of a dipole moment. So dipole moment is over. So electric fields and charges. Anything is left in this? Any concept is left? Just tell me. Flux, yes. So flux. Flux means we have to discuss about Gauss law. Flux. Electric flux. Conceptual questions are coming along this electric flux. See here, this is a positive charge, this is a negative charge, and you would have seen there are the lines of flux which are drawn here like this. Electric lines of flux are drawn like this, and here also electric lines of flux are drawn like this. Okay, so what is this? What is the meaning of these electric lines of flux here? Okay, so you should understand why we are drawing electric lines of flux, and here we are drawing that the electric lines of flux are here. It's called as divergent, and this is called as convergent. Electric lines of force are called as convergent, and here they are called as divergent. Divergent means diving from one point. Convergent means coming to one point. So this is the difference, divergent and convergent. Moving away, divergent. Coming, so how do you decide that direction? Why this positive charge is diving away and this is coming closer? That is decided by test charge, which is called as positive charge. And why these lines are stopping here? Why they are not extending? The reason behind that is here. This is the electric field. This is the electric field. Okay. So what do you mean by this electric field? Electric field is nothing but the region surrounding a positive charge or negative charge within which its influence is there. this charge is having influence within this area, beyond that no influence, so lines are going to stop. What is the meaning of that line? Here that line indicates that if you keep any test charge, okay, that line indicates that line is stopping up to here, means if you keep any test charge which is called as positive charge, beyond this line this negative is not going to attract. If you place this positive charge just here, it will suck inside, that's why direction is in this direction. Okay, the same positive charge, if you keep here, what does it do? It repels downwards and it will stop up to here. Why? Its border is finished. It can repel up to here, beyond that it cannot repel because its influence is within this area. Mana gate local ఎవరు వస్తే దొబ్బేస్తాం. గేట్ బయట నువ్వు ఏమో చేసుకో, గేట్ లోపల వచ్చి డామం చేయకూడదు. ఈవెన్ అడుగుతున్నవాడు కూడా గేట్ లోపలికి రాకూడదు. We don't know what type of person he is. We think like that. So because this is our influence, దీని మీద మనకు హక్కు ఉంది. దీనిలో మనం ముగ్గు వేసుకోవచ్చు, గొబ్బిళ్ళు వేసుకోవచ్చు, పిల్లలు దొడ్డి కూర్చున్నా మనకి అడిగేటోడు లేడు. మీ గేట్ దాటిన తర్వాత కూర్చుంటే అడగవచ్చు. Because I have seen one Muslim lady, one Hindu lady fighting here. And you know language is very dangerous. Muslim doesn't know proper Telugu. Okay. Hello. Okay, I have seen one fight, కొంచెం entertainment, because you might be feeling bored by listening to this very tough concept, very deep concept. One Muslim lady, one Hindu lady fighting in our village. You might have seen, we said that भैंस वाले थे तो सामने, हमारे पुराने घर में जी, उसके सामने उन्होंने बच्चे, हमारे मामू के बच्चे बाजू, they are having many kids. One fellow continuously deliveries, 5 deliveries at a time after 1 year, small children, top to bottom, 5 numbers are there. So one time only they will get latrine. Only 2 latrines are there, one western, one eastern, and where the remaining people will sit. So all children will go and sit outside near the kalwa. They are sitting as if the small birds are sitting on the wire, no? Like that they are sitting like this. Mama, ho gaya, jaldi aa. Anta ayipoyindi paduga nunchi. This type of things are happening. Opposite Hindu lady telling, scolding, yamma buddunde, poddu mukulu bayata ergiskuntu vasana anta endi nu ila kusobedakudada endi ni cheptu మాది పిల్లలు బయట కూర్చుంటుంది, నీది ఏమైనా వస్తుంది? మాకి ఇంతమంది పిల్లలు ఉంది, లెట్రిన్లు 2 ఉంది, నువ్వు కట్టి నేను కూర్చోపెడుతుంది అని చెప్పి గో ఎక్కడ చదువుకోమను, చాలా అతి చేస్తున్నావు నువ్వు, మా ఆయన రాని నీకని చెప్తాను, మీ ఆయన పంపి మన ఇది కూడా జెంట్స్ రాని మాట్లాడు, మా ఆయన రాని మాట్లాడు, మీది ఆయన వస్తే నాకు ఏం చేస్తుంది? గో ఎక్కడ చదువు, మీది ఆయన కూడా నాది ఎంట్రికల్ కూడా పికలేదు. దట్ హిందూ lady say. Muslim lady, how type of sentence forming? I am shocked at that sentence. నీది ఎంట్రికలు అంతా పెద్దగా అయితే జడులు వేసుకో, నాకి ఎందుకు చెప్తుంది? Dangerous language. So this happens. I think you understood the electric lines of flux. ఇప్పుడు చూడు. Okay. Now these are all happening. I'll show you what happens now. One positive and negative comes, how the lines are getting distributed. See, this line will go and this line will go like this and here. Okay, so like this type of flux formation will be there when opposite charges are there. Okay, so next what is going to happen? When same charges are there, what is going to happen? For example, this also positive. Okay, this also positive, this also positive. What happens, no? Like this. It will go like this. They doesn't intersect. Okay, see here. If opposite charges are there, when they are brought closer, they will form a link like this. Strong attraction in the positive and negative. When both are positives or both are negatives, they will come closer and they will repel like this and they'll come back. This is called as magnetic lines of electric lines of flux. Conceptual questions are there. Diagrams will give 4 or 5 diagrams will give and ask which is going to be the correct diagram. ఉంది కదా అలాంటి ప్రీవియస్ ఇయర్ క్వశ్చన్ ఒకటి ఉంది కదా, దర్ ఇస్ వన్ క్వశ్చన్. ఓకే, సో దిస్ ఇస్ ద కాన్సెప్ట్ హియర్.